Welcome back. Previously what we've done is that we actually fit a decision tree or training a decision tree with the scikit-learn library. In this section, we're going to go into and applying this directly to an iris dataset. I'm just going to walk through with you how to actually load the data and then import the tree and then fit the data, as well as later on we're going to show you how to actually visualize that. A couple of basic things. Again, we just need to import from scikit-learn some data sets. The data set for iris is already provided in the scikit-learn itself. I'm going to import tree again, although I've imported earlier, but just to make it easier for you later on, if you just want to copy and paste just this part of the code rather than the whole thing, to save you from having to browse above to look at what libraries you need. Okay, having loaded that, what we need next is really just segregate our data into our two portion. We need the before I do that, let me just visualize it for you. Okay, so iris. Okay, I'll just show this is right now. Okay, so let's have a look. The data type, okay, it's scikit-learn. It's no wonder it's not giving me the data. So let's just show you the 0 to 5. Okay, so the first 5 samples. So what we have right now is really we have 4 features. The so-called name of these is unknown. I'll just show you what they are. So we have the iris feature names. Okay, so you have the sepal length, sepal width, the petal length, as well as the petal width. Remember, iris is a flower, so we're measuring the actual length and width of the sepal and length and width of the petal. And what we're looking at right now is that we are only looking at from 2 and beyond for our feature. Okay, we are not fitting. We're not providing all 4 features, we're only providing 2 features here. So 0, 1, 2, and 3. So really it's only 2 and 3 that we're actually storing into X. That is the petal length as well as the width itself. Alright, and the next thing that we also want to do is obviously we need the Y itself. That's the class that we are trying to actually target. So iris target. Okay, and that's done. All right, so having done both of these, Y is actually where our data for all the different classes. So it's split into 0, 1, 2, 3. Okay, let's do the actual fitting. So we doing a classifier. Let me just set the random classifier. Random state is equal to the typical 42. So that you can actually repeat this exercise. So I'm gonna done the instantiation. We're gonna fit our data. Why do I actually use CLF? CLF means is short for classifier. Okay, so now that we've classified it, and the next thing now really is the we have fitted. Really, the next thing now is to just visualize. Now, one of the beauty of scikit-learn library is that it actually has this built-in visualizer. So from sklearn tree, we can import the export graph viz. Okay, once you've done that, the next thing to do is to actually export the visualization itself. What are we exporting? We need to provide the so-called classifier. We can actually provide the file name, specify the file name. In this case, we're just going to call tree dot. Okay, that actually is the format, by the way, and we want to actually have some descriptor. So we're going to have the feature names as the iris dot features, feature names, and we are only taking 2, so 2 and beyond. 2 and 2. This is the column number 3 and 4, and we need the class names as well, which is the iris target names, and we do want to round up the number. And finally, field is for the coloring. Okay, so close that off and run that. We get an error. The error say got a class names rounded. Okay, all right. Now that that has been exported, we need to actually go over to the actual directory itself and run the following command. Okay, let me just type the instruction here first. Run the following line on your command prompt. This is where you have need to have stored your the dot file that is exported. So I need to actually locate that png. So we're gonna convert the file into a PNG file from dot-o3.png. Oh, not 0. Okay, 0 not. It's O not 0. Okay, right. That is really for you to refer to later. Okay, and as an instructions. Now we're gonna go into my command prompt, and I'll show you how to actually convert that. Okay, right. This is where I store my file. All right. Notice that the 2107 3 dot 3 dot. Okay, so let's just convert this file. I'm too lazy to type the whole thing, so we're just gonna do this and paste this. Would you paste this? Okay, it doesn't allow me to. So dot tpng 3 dot o and convert the file name to png and run that. If it's all done well, you can actually obviously look at the folder itself. Notice that there's the PNG there. The other thing that I'm going to do is just to actually import the file itself. So I'll just import the actual image so that you can actually visualize it here rather than having to go to another location. Okay, so run this. What happened to our file? Let's just have a look here. 3.png. Oh, yes. Okay. All right, there you go. This is probably a bit too big, so let's just width is equal to 60% and height is equal to 60%. All right, so this is what how you visualize it, of course, but more importantly, these are the steps that we've done. We have imported the iris data. We split the features. We're just using two features here, the petal length and width, and we have our target, which are the three classes of iris species. And after we fit our classifier, the next thing now is to visualize it. So the visualization looks like this. I did explain this a little bit earlier. What we have here is the petal width, whereby it's split into two classes based on if the width is less than or equal to 0.8. If it's yes, then it actually fit into this class. Okay, so let me bring back the other visualizer that I used earlier just to illustrate to you. Okay, so we are plotting the petal width and petal length here. So the width on this side, length on this side. So based on the petal width, anything less than or equal to 0.8, which is this line here below, we will actually split them out. There are 50 samples here. The class is Setosa. And anything that is not goes into this class here. Okay, so and what we have next is it less than or equal to 1.75? If it's less than or equal to 1.75, then we get another line here. If it's a yes, true is always to the left. If it's true, then we actually get versicolor, which is this red one here. If it's not, it goes to the purple category where we have the Virginica. So what we have then is that there are 54 in these categories. So we have 49 that is versicolor and 5 that is not. 5 actually belongs to the Virginica. And on this side, for anything that's longer than 1.75, we have bulk of it is the Virginica, which is 45, but we do have one which is mislabeled, not mislabeled as in misclassified, and for that what we get is actually the versicolor is being chucked into that bucket. Just looking at purely this right now, you can tell that decision tree are quite good at classifying, but it also have problem in separating linearly some of the non-linear characteristics from the actual visual that we see here. And how does it overcome? It continues to split. Okay, on it goes. And the next one is look at the pedal length. Is it longer than 4.95? So it draw this line here and continue splitting onwards. All right, I hope that is actually it helps you to understand. Now, the other way to visualize, I'll demonstrate to you. One is using the graph viz. So let me just label this. So we have we are using export graph viz. Now there is another way. This one is a bit trickier. It depends on whether you have actually installed correctly or not earlier. The library, remember earlier when I actually showed you the documentation the previous 2 videos ago, when we actually create the environment, this was the library that we installed. Okay, so if it's installed well, then you will be able to run this line well, graph viz. And we're going to store this into .data, and we use the tree export. Again, this is actually similar to before. And we're going to do this. At this time, however, we are not going to export it out. File is none. Okay, the next thing though is that we do need to provide the name. Let me actually come up here and copy these. Save you some time watching me type, which is torment sometimes at the best of time. Okay, right, so tidy this. Okay, so that's essentially what we want to do. All right, store that into the .data. Then what we can do then is actually visualize this by using this graph is equal to graph phviz graph viz and dot source is dot data that we created. Okay, so then we can graph this. Again, it's a bit too big, but this one I can't change the size. Notice that with this tree, the actual splitting is a little bit different. It starts with, is it less than or equal to 2.45 for the pedal length? Let me see if I can pull back the visualizer here again so that you can actually visualize that as well. Give me a sec. Okay, yeah, you have the pedal length. This one comes from the pedal length point of view. So it cut from this line. Okay, so it start from this angle. And if it's less than 2.45, which is roughly around here, it will be true. And that's 50 observations. It goes to Setosa. So in essence, the good thing about this is you can cut it this way or cut it this way. With this tree, it starts from here. And the next line is that if it's false, then it goes over to pedal width, which is this one, which is similar to what we had before. And we repeat the whole process again and again. So those are the two basic ways that you can actually visualize this, and and both are viable, both are good for you to actually, quite good to actually visualize this, to actually get a bit of an appreciation and understanding. I'm going to come back to the genie a little later. It's nothing to do with genie in the bottle. It's more to do with the how it actually segregate the two classes or the three classes, or how does the actual decision tree is built. It's built based on genie. Right, having done that, the next thing that I do want to do is continue with this visualization theme. But what I do want to do is actually demonstrate to you how do you actually plot a scatter diagram and visualize the actual decision boundary. So we can see it right now, kinda in a way, by looking at the tree itself. But what I do want to do is just to show you another way to actually split the decision boundary. Okay, so we do need to import a couple of other libraries. We need to import NumPy. Shouldn't have done that. Next thing is import Seaborn as SNS, and we're going to set the style. And as white grid. And I'm going to import matplotlib. Matplotlib.pyplot as plt, and we're just going to plot the chart matplotlib inline and run that. Okay, so let's just again, I'm just going to import the data, but this one I'm going to import directly from Seaborn rather than using the existing one. Okay, so I'll let you visualize that. df.head. Okay, so this is what it looks like. We're not gonna plot everything. We're just gonna, again, just using these two features here because it's easy to actually visualize. Again, with y is our species, but the slight difference is that this time around we're gonna use the label. That's the reason why I'm using this rather than using the other data sets, because the other data set label is 0, 1, 2. And with this, I am having it as in the form of the text or string here. All right, we've done the so-called preliminary preparation, storing x, storing y. We've fitted now. The next thing now is really to plot this. I'm going to use my codes earlier and just repeat then. Essentially, we are trying to actually reshape the x values so that it create a mesh here so that we can actually plot in terms of the boundaries. And we're going to run the prediction on all of these mesh of data. Basically, we're chopping up into fine bits or fine matrix, and just let the classifier predict every single one of these. And we reshape that so that it plots nicely, and the color and everything is just left as it is. Okay, I need to run this line first before I run this line. Okay. What do you see here? We have very similar picture as the one that I showed you before, and this is really the decision boundaries. With this, you can clearly see that it starts off from the sepal length itself. All right, where was it? Okay, I think I need to pull up the other picture so that you can actually visualize that here. All right, give me a second. All right. Okay, so start with the petal length. Okay, it's start with the petal length. It chop it off from the 2.45. After that, it using the decision tree, it actually cut it through from here, and then it start to actually develop other decision, other node. So which is this one here. So you have the 2.45. It splits into 2, and then 1.75, which is this 1.75 line here, and then after the 1.75 line. Then it actually start to look at the petal length itself, which is this column here, the petal length itself. So on it goes. So this is how you actually visualize it. You can start to see there's a bit of a problem in terms of overfitting. It's really trying to do a lot to actually fit that in. And this is how decision tree deal with non-linearity, and it can go a little bit too far and start creating a problem of overfitting. And that's really where we actually start switching over to ensemble learning to actually overcome this problem. With that, that's really the end of this lesson on how to visualize a decision tree. But before we go, there's always exercise, and this exercise really is for you to actually, again, like I said, is to cement your what you've learned here. And we have done the classification in terms of training. This is applying to the Iris dataset. I want you to actually come back here, and this time try it on the sepal length. Okay, I do have to warn you though, it might not actually segregate as well, but nevertheless, I'd like you to actually try that out, and then walk through the export graph viz option. Okay, and also try the second one, which is graph viz. You can use my code, and finally visualize the boundary, which is step 3 here, so that you can get a nice picture here to actually visualize to see how the decision tree actually chop them up. Right, with that, that's really the end of the lesson here. What we've done is that I've shown you 3 ways to visualize, and when we come back, we're gonna start looking at the actual algorithms and do a little bit of deep dive, and just to understand the algorithm that decision tree used to actually split each of the node. I look forward to seeing you then.